Okay, hello everyone. By the names, I'm Mulavi Zajuma, and I'm doing MYT, that's year 3. I'm here to give some simple explanation about the memory management assignment, and I will start with my introduction, which was kinda simple, where I defined the term memory as a collection of data in a specific format, and memory management in operating systems is so critical. It's a critical component responsible for managing a computer's physical memory, that's the RAM, and the computer's virtual memory. Then, its primary goal is to allocate and deallocate memory resources efficiently, ensuring that various processes and applications can run concurrently without the interfering with each other. And basically, that's a deadlock in case there is a fight for resources amongst the different processes in an operating system. I have my next slide will talk about memory allocation, whereby in operating systems it involves the process of assigning a portion of the computer's memory to a program or to a process. And here I basically talked about the contiguous memory allocation, where a process is allocated a single contiguous block of memory. Though this can cause some external fragmentation, as we shall see it in the coming slides. Then I talked about partitioning, where we had fixed and variable, and with the fixed partitioning, the partition vector or the size vector does not vary with time, and with the variable partitioning, the size vector varies with the time. You can specify, you can give a specific period of time, maybe t, and you find that with the variable, it varies with that time, and with the fixed, it does not vary with that time specified. And I talked about fragmentation, which is a phenomenon where the continuous allocation and deallocation of memory leads to subdivision of a free memory space into smaller or non-contiguous fragments. And we have two types of fragmentation, that's external and internal. For external, all out memory space is sufficient to fulfill a solicitation in it. However, it isn't adjacent, so it can't be utilized. Meaning, with external fragmentation, the solicitation is not adjacent, so it can't be utilized. And then for internal, here memory square appointed to a process is greater. Some part of memory is left unused as it can't be utilized by another procedure or process. Uh, Let me go to paging, which is the division which divides the logical and physical memory into fixed sized pages. With the paging, I talked about the principles of its principles of operation, page allocation, and then hardware support for paging. Then let me talk about one by one. Principle of operation. The first part is division into pages, and this involves breaking both logical and physical memory into fixed sized pages. And then logical address space. The logical address space of a process is divided into pages of the same size. So here the logical the logical address space of any process or activity that is going on in the operating system, it is divided into pages of the same size. And here when we got physical memory, the physical memory is divided into frames of the same size as the pages divided in the logical address space, meaning each physical memory frame has to be of the same size as the page divided in the logical address space. And then page allocation, you have a page table, a page fault, and a page replacement. Page table, each process has a page table that maps logical pages to physical frames. As we seen in the previous slide, each frame has a page size that it matches with. So here, the page table is where each process has a page table that maps logical pages to physical pages. And then page fault, it's where a process references a page not currently in memory. Here, it's like a process tries to call a page that is not in memory, and this causes a page fault, meaning if that page is not in memory and a process is referencing it, an error will occur, which is called a page fault. And then page replacement, the operating system selects a page to be replaced, and the required page is brought into the free frame. That's the physical frame. Hardware support for paging, basically I just outlined some few here with some simple explanations, where we have the memory management unit responsible for address translation, then page table base register, which points to the base of the page table in the memory, and translation look aside buffer. This is abbreviated as TLB, a cache of page. It's a cache of page table entries to speed up address translation, meaning basically this one, it does the speeding up of page of address translations. And then protection and sharing. Protection, paging enables memory protection by marking pages as read only, meaning the paging process enables memory protection, meaning it protects the memory by making them read only. And then here I talked of the disadvantages of paging, as whereby page table requires additional memory space, so it may not be useful for a framework having little RAM. If paging takes memory, meaning it will consume it will take part of the computer's RAM, which may end up slowing your machine. And then I talked of virtual memory. It's a memory management technique that provides an idealized abstraction of the storage resources that are available on a given machine, whereby virtual memory improves the performance over swapping a computer system. Hardware and control structures have memory management unit, as talked about in the previous slide. Then page tables, page fault handler. The page fault handler just avoids a page fault from occur, or it works on a page fault in case it has occurred. That's the main function of a page fault handler. All those are hardware and control structures. And then if we talk about the locality of reference, we have temporal locality, spatial locality, and the utilization. With temporal locality, this principle suggests that if a memory location is referenced, it is likely to be referenced again in the near future. Whereas spatial locality, this principle states that if a memory location is referenced, nearby memory locations are also likely to be referenced soon. Meaning, after any memory location getting referenced, nearby memory locations, very soon they will be also referenced. And then when you go to utilization, locality of reference is essential for optimizing the performance of virtual memory systems. It allows the system to predict and prefetch data, reducing the frequency of page faults. That's about utilization as another form of locality of reference. I talked about 3, then I had here some more terms to talk about, whereby we have a working set. The working set of a process is the set of pages that it's actively using during a specific time interval. Working set, like I can say they are the active pages used by the process in a specific time interval. And then a data page is a page in memory that has been modified since it was last loaded from or saved to a secondary storage. Here the secondary storage, you can think of maybe any disk. Yeah, a disk. Then demand paging. Demand paging is a memory management scheme where pages are loaded into memory only when they are demanded by the program during its execution. Meaning, here, in case a program is executing and it needs a certain page, that's when that page is loaded. If not, it's not, meaning it's on call, on demand, it's loaded on demand. And then we have some page replacement policies. We have optimal, first in, first out, which is the FIFO. We have second chance. We have not recently used, and then last recently used. If you are to talk about the optimal page replacement algorithm is also known as the Laddy's optimal algorithm, which selects the page that will not be used for the longest period in the future. So this one, it selects the page that will not be used for the longest period in the future, and it is replaced. And then first in, first out, this one is just as you hear it, first in, first out, meaning the oldest page or the page that has stayed longest is replaced. And then second chance, it's an enhancement of FIFO that gives each page a second chance before being replaced, meaning if it has stayed longer and it has to be replaced, it's given a second chance before being replaced, and that's second chance SC. Then not recently used, this one replaces the pages that are not commonly used or that are not used like oftenly. And then last recently used replaces the page that has not been used for the longest period, meaning if there is a page that has stayed for a long time and it has never been used for that much, then that's the last recently used. That page is replaced. This comes to the end of my tutorial. Basically that is it. By the names, still I remain Mulaiza Juma, doing MIT Year 3. Thank you for your time. Thank you for listening. Bye bye.